Well, when I'm going to start. Hello, everyone. I am Laura Jimenez. Thank you for joining us today. It is a pleasure for Forza to have you here. I am an architect and Forza sales manager of Middle East and Africa markets. Today, I will be hosting this conference about technologies for improving productivity on site. Our speaker for today is Santiago Martinez, civil engineer with over 10 years of experience in construction management and technical support on site. Santiago is a passionate construction specialist and has been working with Forza for 5 years now, leading the implementation of industrialized construction around South America, the Caribbean islands, Africa, and Saudi Arabia. He's an expert in improving construction project productivity and one of the best of our best site engineers. So please, let's give him a warm welcome. And don't forget to write your questions in the box below. We will get to them at the end of the webinar presentation. Welcome, Santiago.
Hello, Laura. Hello, everyone. Welcome to this webinar. Yes, as Laura was saying, today we're going to be talking about technologies for improving productivity on site. Just a little bit more about my resume, about my experience. Yes, I'm a civil engineer from the Javeriana University here in Colombia. I have been working with these kinds of construction systems for almost 10 years now. I have done the industrialized system with formworks, multi-story buildings, different kind of houses made of masonry and concrete themselves, and the precast system. So today we're going to be talking about this topic, and welcome everyone. I hope you find it interesting. So basically, let's begin. So, as you know, nowadays it's very easy to find that any product or service it's made on in a series. Yes, looking for mainly profitable, productive, and efficient results. Yes. Here we see some examples of some products, but basically we're going to be focusing about how this impacts or affects the construction business. So building in a series is possible, yes, and that's why we couldn't be left behind in this kind of businesses. So this is why the formworks appear, you know, to improve our productivity on site, or efficiency, or times, etc. So no, from now on, we're going to be talking about different kind of topics, and this is mainly what we are going to be talking about. So, in terms of the project, what do we look by industrializing? Yes. In terms of the project, basically the speed. Yes, of course, we're going to be able to make projects faster. Yes, we're going to be able to pour at least one house a day, or that's the mainly aim that we focus on. We're going to have precision in construction times. Of course, basically, we know the performance rate. We know that, like I just said, we can be able to cast one house per day, one apartment per day, depending on which project are we talking about. We're going to have efficiency with project control mechanisms in terms of cost and time. We're going to be able to know exactly what are the costs that we're going to find daily, weekly, monthly, knowing how many people do we need, what are the materials, basically everything that involves the normal procedure of you know the housing business. And we obviously look for correct finishes. With this kind of systems or formworks, basically, we try to get the best finishes possible so that we are able to start working on the finishing of the house, basically, as soon as we disassembly or formworks, and looking the less reprocess or the less repairs needed in our system, in our project. In terms of organization and planning, we're going to have a financial planning. This comes with the thing I was just saying. We're going to be able to know what is the cash flow that we're going to have in the project, because we will know how many people are going to be involved. How many people do we need to do a daily cast or a daily pour? We're going to know exactly we're going to be able to make our purchasing department knowing exactly what to buy and when to buy it. Yes, basically we're going to be able to manage our warehouses and always be able to have everything that we need, to ensure the correct rate or procedure of our projects. And we're going to be able to coordinate our activities, because we're going to be in control to know basically what are the activities that are going to be done during a day. Yes, we're going to be able to have our assemblers party. We're going to have our steelers. We're going to have our MEPs or mechanical, electrical, plumbing crews organized. So everything, this kind of systems helps to be able to coordinate them. Yes. In terms of costs, of course, we're going to be able to do a compliance in terms of the budget, because these kinds of systems are much easier to be able to control them, because we're, like I said, we're gonna be able to know exactly what is done, what is required to make a house daily, to make an apartment daily. And we're gonna see later in the presentation that in other kind of systems this gets harder, because we don't know exactly how many times. Maybe the results are not going to be the same every time that we finish a house. So this is basically what this kind of system allow us to do. Control of materials, like I just said. Elimination of dead time, because every worker will know exactly what are the tasks that he must do during a day, a work day, and they're not gonna be waiting for another kind of activities to start their tasks. And this obviously results in a better labor utilization. But how can housing and buildings be built in a series? Here we see two pictures of some projects in Brazil. We need to define the construction system. Yes, we know that the major amount of housing units, the more profitable and suitable it is to work with an industrialized system. Of course, if we are going to do one single house, it might not be proper to get an aluminum formwork, because the price of the set is going to be very comparable to the cost of the house and how are we going to sell it. Yes, but the major units we find in housing units, I mean, this way it's more suitable or profitable to work with this. Yes. Basically, we need to define how many sets are we going to work with. Yes, that depends on how much time, how many time are we trying to to deliver the project to the final customers. And this also involves, like I said before, that in terms of cash flow, are we able to get 2 houses per day, 4 houses per day? We need to define by deciding this, we need to know how are we going to plan the project? Yes, how many cubic meters are we going to cast in a day? How are we going to put it? If we're going to have a crane, if we're going to have a pump, this all needs to be decided, by selecting the best option we can. Yes, we need, like I said before, to optimize the use of materials, better utilize the workforce, avoid inefficient routines, and of course, eliminate waste. In terms of waste, the formworks are much better to work with because they will be minimized. So here we have a chart in which we are going to compare the different kind of systems. Basically, we're comparing the framing system, which means columns, beams, slabs. The traditional way of building houses. We're going to have structural masonry. This is also known as a traditional system. In the right part of the presentation, we find the industrialized systems. There we will find the aluminum formwork, the steel formwork, and the precast system. So we're going to be comparing them by different kind of factors. The first one, like I said before, it's the speed of construction. Yes, so basically in the framing, the first idea that comes to our minds is that it is not monolithic. I mean, we need to cast the columns first in order to be able to pour the slabs. But we don't know in how much time are we going to be able to do it, because it's not like assembling a house in a day. So it might take sometimes less time or more time, and there comes the uncertainty and the dead times that I was talking, the dead times of the labor that I was talking in the previous slides. In structural masonry, it is not monolithic also, and we know it's a different kind of construction. We need to use blocks or bricks, and that is not like a performance that it's always going to be the same. Yes, we need to, obviously, in terms of the walls, we're gonna have to go up, looking for some kind of columns. So basically, it won't be done in a day. It won't be done in a day. We can say that it might take at least 1 week for a housing unit, because there are many activities involved in a masonry system. The aluminum formwork, which is the premium work, it is a monolithic system. It can also be done independent, but we're going to be talking about that later. It helps us a lot to be able to assemble it in a single day with not specialized labors. I mean, this kind of systems are learned very easily and very fast with the people, so that in terms of a learning curve, they're going to be able to work very, very, very fast, very rapidly. And it is a handheld system. The standard panel weighs around 27 kilos. So with just the man force, we're going to be able to assemble them in 1 day. Then we have the steel formwork, which works a lot like the aluminum formwork. Basically, the main difference from the steel and the aluminum, it's that it is heavier. If one of a standard panel of aluminum formwork weighs 27 kilos, if it is a steel formwork, it will be a lot heavier, so it won't be easy, or the productivity or efficiency by man hour are not going to be the same. The precast system, it's not monolithic like the other systems I was talking about previously. The wall formwork is assembled on the first day, but the concrete will take longer, and also the slab. It is a mechanized system. We're gonna be needing a crane to work with, and at least we can say that it takes 2 days for a housing unit. In terms of number of pieces in the framing, this little part, it's in Spanish, sorry. To build 1 square meter of you know of a wall or something, we need to at least be able to carry and glue at least 33 bricks. So basically a lot of work to achieve 1 square meter. In a structural masonry, it will be the same. I mean, in the framing system, it's common to, you know, to close the perimeter of the house or the building by using bricks or another kind of material. In the aluminum formwork, this is achieved by just 1 piece, by just 1 standard piece. The steel formwork, like I was saying before, it is heavier, so the dimensions of the panel are smaller. Yes, and in the precast system, you need to involve the welding part of the process. So it's a lot of, you know, like a lot of activities to achieve 1 square meter of a wall or a slab, depending on what we are talking about. So in terms of labor cost in the framing system, every stage will require their crew. Yes, like I was saying, first you need to crew to cast the columns, one to cast the beams, one to cast the slabs, and the others that are going to close externally and internally. So we will need a lot of man work in the structural masonry. We need specialized people because not everyone is going to be able to get good productivity. And in the aluminum formwork, like I said before, we need less specialized workforce. It is a very simple system and fewer pieces. The steel formwork works mainly the same with the previous notes that I gave or differences between the steel and the aluminum formworks. And the precast system, of course, we need a very specialized workforce. And also we have many activities, like I said before. In terms of cost of materials, of course, we're gonna be getting differences between this kind of system. For example, in the framing, a lot of waste and debris is generating from the brick cutting. It can be like at least 6% normally. 6% that becomes waste. Waste in mortar, I mean cement, sand, and water, you know, to glue the bricks. Lots of wood or whatever formwork is needed to you know, to cast the columns, beams, and slab. So there are lots of materials, you know, in a framing system. In the structural masonry, it basically talks about the same as before, because we need to pour some small columns in order to structurally, you know, to get to the structure to behave structurally well. And in the aluminum formwork, you know, basically we're gonna find a release agent or the formworks it's themselves, and it doesn't require a lot of shoring, because in the framing system, we will need to cast the very large slabs, and we're gonna need a lot of shoring to support the weight of the concrete, the steel, and I mean the slab itself. The steel formwork works the same, and in the precast system, we're gonna have higher costs in the transportation of the panels, because they are normally done in a factory, which can be, you know, very a part of the project. It does not require release agent, but it requires the welding and you know, preparing the mortar to close these joints. It might not require wood, and it doesn't require a lot of shoring. In terms of finishings, in the framing parts, too many controls are required to guarantee apparent concrete. You know, if we use wood to cast them, of course, the surface is not going to be the same as using a steel or an aluminum formwork. We're going to have short lifespan and a lot of reprocess, from the thing I was just saying. And the controls, yes, we're going to be very, very, we're going to be very meticulously checking the plumb, the levels, and everything that, that affects the geometry of our structures. Structural masonry the same. The aluminum formwork, dimensions and geometry are maintained. If we do a good control in the assembly process and in the checking process before casting, everything is going to be okay. It also works with the steel formwork, but the steel formwork, it's more commonly used in independent systems in which the walls are casted previously and then the slab. And in the precast systems, we have good finishes, but there are a lot more activities, like I said. Initial investment, well, in the framing system does not require a major investment. Brick, wood, cement. The structural masonry, it works the same basically. Aluminum formwork, we will need to buy, our sets. But we're gonna have a longer lifespan than using steel formwork. And the precast system, of course, every wall is going to be bought or acquired. And in the architectural design, the framing system it's normally used in simple projects, but in further activities or stages of the project that can allow us to work a little bit with different kind of designs. The structural masonry won't be very easy. It won't be very easy to work with special designs or special architectural designs. And in the aluminum formwork, of course, like we're gonna see later in the presentations, we can be able to do any kind of detail and any challenge that we find. The steel formwork, it's not as it doesn't allow as much as the aluminum formwork to work with special designs. And the precast system, like the masonry one, they are basically used for simple projects, like linear walls and slabs with just one level and without a slope. So basically, this chart resumes or shows everything that we have been talking about. Basically, the aluminum formworks, as you can see in the last column, would be the more suitable thing to work in terms of the factors that we were just looking at. So we're gonna be talking about what are the main the main actors that are involved here in this kind of systems. Of course, we're gonna find the concrete. This is basically what is going to be poured in the formworks. The formworks will work as a mold, as a structure to be filled with concrete. And in the inner part, we're gonna find the steel. The steel will allow us for the structure to behave properly and according every country normativity or code. And of course, we need the labor, the ones that are going to operate our sets or everything that involves everything that is involved in the daily works of this kind of construction systems. Here we have a project. This photo was taken in Brazil a long time ago. This project uses 6 sets of formworks. Yes, 3 duplex. Yes, to be able to have 6 apartments per day. So basically, the benefits, we're going to be talking about the benefits of using this kind of formworks. So they allow them to be handheld. Yes, you can see these towers in the picture. We see no crane here. There is no crane needed. Basically, we're just gonna need a machinery to be able to pour our concrete. But everything is done by man work. Everything is done by man work. we have three fronts like I said, there are three duplex working at the same time in the project, and everything is done with labors basically. The pumps are moving from one tower to the other, but 6 apartments are done mainly in a day. As you can see, there are 8 apartments per story in this project. So basically, in one day, we have 75% of one story of the project done, which is a very efficient rate. The levels of finishes on the concrete, like I said before, are excellent, and it allows us to start working the day after with this assembly, sealing the tie holes in the walls, and if we want, we can start plastering very soon, or plastering or refinishing. In terms of architectural designs, they can be adapted from one project to the other. Here we have a photo of a hotel in the Caribbean islands. As you can see, they have some special balconies. This is done by our formwork. But what we look for when we start modulating a project is the project to be modulated with the most amount of standard panels as possible. Yes. The more standard panels that we have, the easier it will be to adapt them to a new project. So basically, that's what we look for, and it might take around the 70 or 80% to be used in the next building. It is very important to know that when we acquire some panels and we think that we're going to be needing them in a further project, to be able to analyze the designs and to get the most of the panels working, not changing the free height of the project, the windows, for example, the door openings. Basically, if we as we maintain this, the higher of the percentage will be of the reused panels in new projects. Of course, we have a very long lifespan, like I said before. We can have at least 500 uses, depending on which type of formwork is acquired. But but with a good treatment of the formwork, not letting them fall, not impacting them with a hammer, and keeping a maintenance process, cleaning it every day, using release agent. We have been able to look sets of formworks working, for over 2,000 or 2,500 uses. I have seen this myself in different parts of the world. So basically, we're getting a durable product with this kind of formworks. So we're going to be talking next about the architectural designs and how this can be done with aluminum formworks. This photo is very interesting. It was taken in Guatemala a long time ago. Everything you see in this house is done by aluminum formworks. The frames, the sloped slabs, the windows details around them. Basically, the only thing that isn't done in concrete is this protections of the balconies. Yes. In terms of the structural design, when we start designing them architecturally, we need to take into account that this is not going to affect the structural design of it. I mean that the wall, that the mesh, that the reinforcements are able, to work properly inside of our formworks. And basically, for example, here in projects of this part of the world, in South America, Colombia, we find that many structural designers start, reducing the width of the wall as we get higher in the stories. For example, from the first to the fourth floor, we have 12 centimeter walls. From the fourth to the eighth, a 10 centimeter wall, and the last two or three stories are done in 8 centimeter. These systems allow us to do that. Of course, we're going to be changing the design, and we will need additional pieces, but it can be done. We can have different kind of details done with this formwork, like, curved facades. We have done a lot of projects that have been some challenges from us, but like we like to say in Forza, we can do the tailored suit of the project that you need. Yes, we can have diagonal walls, we can have cornice type finishes, and they can be done monolithically. I mean, one single pour, we can achieve everything that is required in the architectural part of the design. So in this slide, we're going to be talking about the difference between independent systems and monolithic systems. Yes, with working with formworks, we can be able to work in these two kinds of works. Basically, independent system means that we're going to be pouring first, in a first stage, we're going to be pouring the walls. In a second stage or later stage, we will pour the slab. This is mainly done to be able to start pouring the walls earlier, because in the monolithic system, we need the slab formwork to be fully assembled, and all the mesh, all the reinforcements, all the pipes, all the I mean, everything that comes in the slab needs to be done in order to start pouring. In the independent system, we can start pouring the walls. Of course, there are differences by working in the two of them. Basically, we're gonna have more reprocesses in the independent system, because we will need to work on the perimeter. I mean, the internal perimeter of the house, in the junction between the walls and the slab. Yes, by doing it monolithically, everything becomes stiffer, and it also makes it easier to find better plumbings, better levels, better corners. So of course, we recommend to use a monolithic system. So here we have the definition of basically a formwork. Basically, the panels that are joined together form a temporary self-supporting structure capable of withstanding pressures with minimum tolerable deformations in order to shape the concrete according to the architectural design. Yes, as we saw before, a formwork can be made of steel, wood, plastic, aluminum. Different kind of materials are worked with. In terms of the pressures, for example, our aluminum formworks are designed to be able to bear 60 kilopascals, and we can guarantee that we're gonna have finishes at maximum 3 millimeters. That's the tolerances that we manage here. So as you can see, we're gonna be needing a very thin, a very thin layer of the plastering or the material that we use to get the finishes of our house or our apartment. In this slide, we can see different types of formworks. Here we have, of course, there are going to be a lot of pieces missing, but these are the basic ones. The first column, we have the wall panels. It's abbreviation of the Forza slang. Let's call it. It's FM. The standard size of it's 60 by 240. Basically, the weight of them can be around 22 or 23 kilograms. In the next column, we have the slab panel. Its abbreviation, it's FL. The normal size of this panel, it's 90 by 120. But for example, in our new product, the Forza Pro, this becomes 60 by 120 because of other considerations that we can discuss in further presentations. We have the wall slab union. Its abbreviation, it's EQL. Basically, it's the way that we are going to connect the walls and the slab. We can find different kind of these elements and different heights. 7 millimeters, for example, that's the knife ledger or the razor, and we can have them by multiples of 5. I mean, 5, 10, 15, 20, 25, 30, depending on the architectural design. Other types of elements are the caps. Basically, they're the ones that go up in the walls and allow us to get to the height of the free height plus the thickness of the slab. We have the internal corners that are going to be used. By, as it names suggest, in connecting two wall panels in the corners. We have door and windows covers that are the ones that close the walls in order to get door openings or windows or any kind of thing that we can find in a normal building. Here we have the accessories, fastening accessories. They're made of steel, basically. They are used to join panels together. We have the basic types, the arrow pin that comes in the Forza Plus panels. We have the padlock clamp. We have pins, short, medium, long pins, depending on where and why are they used. We have the staple pins, the wedges that comes inside the pins, and the ties. The ties are the ones that we use to ensure that the wall thickness is conserved or preserved. We have different kind of alignment accessories. We have the Whaler brackets, the wall braces, the door and window braces, and the cup wall aligner. They're used, to get good verticalities, good alignments, to ensure, like I said before, door openings, in order to be able to find the best geometry possible and the best kind of specifications in our designs. We have different kind of tools. Yes, they are used, to assembly or to disassembly the forms. We have, for example, the panel remover, the tie puller, the leveling crowbar. Different kind of tools can be acquired. So different kind of markets and situations and normativities and codes have made us, take a lot of considerate. To consider the importance of the security systems. Yes, Forza has a full security system made of scaffolding, platforms, and guardrails. We have a picture in a project of Brazil. We have the assembly and disassembly security system, which is the one in the lower part, and we also have these guardrails that are used or are done in the pourings. Yes, this is very important to ensure the security of our labors. This obviously affects and impacts the efficiency because they will be feeling safer, they will be feeling more secure, and of course they're going to be able to do their work faster. Here we have a detail of our, or like a basic formwork it's assembled. We have the wall panels. Yes, here we have a Forza Plus with 2 ties. We can have different configurations depending on which type of product are we using. Above them, we have the wall slab union. In this case, because it has it has a tie. Its height will be 20 centimeter at least, and the way it connects to the slab. In the right picture, we have the caps, we have the wall slab union, and on the slabs, you know, to be able to cast the upper slab completely. So what are the inputs and outputs that, you know, or the process of modulation and the inputs and outputs that are required? So basically, we will need an analysis of the blueprints or drawings or plans, the way you want to call it. Of course, they need to be the final versions of everything. It is important to check that these blueprints, you know, are totally compatible with the other kind of drawings. I mean, the structural drawings or the MEP's drawings. You know, that it maintains the width of the walls, their dimension, and everything. And of course, we're gonna do a file rectification, yes, or a debugging them, you know, taking into account only what is going to be built in concrete. We're gonna see some examples later. If needed, we can do a 3D, you know, a 3D model to understand better the modulation that needed in every project. But for example, the stairs are always done in 3D. Because this is needed in the project or inside to be able to assemble it faster and better. We of course give a project modulation, pretending to have as much standard panels as possible. Like I said before, we do a final 3D modulation, and we need to do production or manufacturing blueprints that are used in our factory for the ones that weld them, that assembly them, and basically all the people that are involved in the manufacturing process. So here we have some examples. Here we have an example of a small house, an architectural drawing. It's important to have the axis very clear, the dimension that the information it's capable of reading and you know, as clear as possible. It needs to have, you know, details that are important for the engineering department to take care of or to consider. In the right part of the slide, we have the debugged plans. In this example, we have some walls that are colored in gray, some in purple or in blue. And this, for us, it means that the widths of the walls are not the same. For example, this can be 10 and 15 and 20 centimeter widths. So basically, this architectural drawing on the left becomes or the drawing on the right for Forza to work with. Like I said before, sometimes we need to do a 3D models. This is one design that we had, in which we had lots of you know, considerations to take into account. And so when needed, we do a 3D model to understand what is required from the client, and that so this way our clients can approve them or make changes to them. The next step will be the modulation drawings, plans. On the left, we have the walls. Like I said before, we will try to get as standard panels as possible. We can see some openings of doors, which are painted in red, or windows. And on the center part of the slide, we have the slab modulation. As you can see, once again, there are standard panels, you know, as much as possible, or modulation will consider this always. We will have 3D modulation of special designs, you know, delivered to our client. For example, on the left, we have this frame on the inside of the house. This is the entry, and in the next one we have um, an hexagonal or octagonal um, this design of this kind of windows. This is important for the assemblers to know which piece comes exactly and to be able to assemble it as faster and as simple as possible. And the final stage would be the production blueprints or the manufacturing drawings. These are done internally. So like I said before, every person, every labor from our factory would be able to understand what are the technical specifications of the piece, their dimensions, where the drillings are going to be located, so that everything adjusts and you know and the panels will be able to yeah to be assembled perfectly without any problem. So we're going to be talking about architecture typologies, which is another situation or consideration that we need to take into account. Basically, we have this multi-story buildings in which we have the case that the apartments on the edges are not the same as the central ones. So in the upper part, we have two cases here. The upper part show us a duplex set. This is the pouring sequence. We have, like I said before, 8 apartments per floor or per story. If we had duplex, we can do an edge apartment and a central apartment in every pour. We will be doing the whole story in 4 days, and the assemblies are going to be the same, you know, the same size, basically. And in the lower part, we have a single set. So we will be doing the whole story or the whole floor in the double of time. We have this pouring sequence 1, 2, 3, 4, 5, 6, 7, 8. We will, of course, if we work with the upper option, we will need the double of people. We will have to pour the double of concrete. We will have to put the double of mesh, of pipes, or everything. So it is important, you know, to take into consideration how many sets are we able, you know, to, or can we, is your project suitable to work with? In the lower part of the lower case, we will be changing the size of the assemblies every 2 days. Yes, the 1 and the 2 are going to be the same. The 3 and the 4 are going to be higher. The 5 and the 6 would be also the same. With some changes in the corridor, and we will end up with the same 7, 8 smaller assemblies. So this is something we can talk about in a further webinar. Basically, I'm going to show what the construction process is. First, we will need to take care of the foundations, you know, to have them very well checked, their levels, their corners, the start of the reinforcements, the pipes, that everything is inside our walls, so that we won't need any reprocesses. We'll need the installation of wall mesh further, electrical, sanitary, hydraulic, and gas installations in the mesh, the installation of separators or spacers are the ones that ensures the covers of the concrete. Later, we will start assembling the wall forms and the slab, of course. Assembling the slab reinforcements, we would pour the concrete. Then we're going to strip the walls or disassembly them, and basically this is going to be the sequence of the process. Of course, alternately to the technical process, we will need to perform a maintenance process in which we need to ensure, like I said before, the lifespan of the products that we acquire. We need to clean them every day, daily, We need to focus on the well treatment of the panels so that the laborers don't impact them with a hammer. They don't let them fall. It's important, to be checking this in a daily basis, applying the release agent, and taking all the concrete waste out of them. This is very important also. So what has Forza been doing, to improve the productivity of our clients? As you know, Forza has been in this market and this construction business for more than 25 years. So we have focused in basically 6 key factors or 6 pillars that we call them, to improve the productivity of our clients. The first will be the reduction of the weight, like we saw. The lighter the panels are, the more efficient it will be for us to carry them, to assemble them. We're gonna have basically an improvement of the times and the speed of the products, and of course by having lower weight, it will be more suitable for us. Of course, the weight depends on which kind of product we use. The second pillar is the reduction of accessories. In this case, we have a two-tie wall system. By reducing the accessories, basically we're gonna have less reprocesses, because we won't need to be filling the tie walls holes and sealing them. This will make everything faster. It obviously it's better for everyone involved to have less accessories. This is a photo of an example, having 8 wall ties versus having 2 of them. Like I mentioned, it will depend on what are the requirements of our clients and the product that they acquire. The third pillar is that we are always trying, for our system to be very intuitive. I mean, as simple as possible for the assembler, that they get to a learning curve very fast. And we are always trying to make things simpler, or accessories, or panels, or tools, or drawings. Everything needs to be as simple as possible in this construction system. Of course, we are always working of having less pieces per square meter. This will, of course, impact in less junctions, less repairs, less accessories, like I said before, and this will affect our efficiency, and it will be better for everyone, for the assemblers, for us, for Forza, for the factory. So we're always trying to improve this. Like I mentioned before, the safety systems are very important. We need to take care of the life of our laborers. So we are always trying to improve and try to get new technologies in order to be able to maintain a good efficiency, working safely, basically. The sixth pillar will be, like I said before, improving productivity, but this means more like in new kind of product. Here we have a climbing system. Basically, it is done by high-rise building. In this kind of system, we pre-assembly all the external walls, and they are moved with the help of a crane, and the internal walls are operated by laborers. This we're gonna see an example of this later. Basically, it's this one. This is a project from Lima, Peru. It was a 20-story building with 8 apartments per floor. They had a duplex. I mean, they poured 2 apartments per day. that was like 130 square meters. So the story of this project, it says that they started, with a force loom type of formwork. They took 5.5 hours to be able to assemble them with 22 men. They had a yield or a rate of 1.1 square meter per man per hour. Later, they acquired a plus system, yes, and with a with a safety system also, and the time was reduced by half an hour, 5 hours basically, but they reduced 2 men, yes, so they got an improvement of 8% in the yield. And finally, they got convinced to work with our gang and climbing system, which is the one I showed you in the last slide. So they reduced another half an hour. I mean, time is money, like we always say, and they reduced 2 men also. So from the beginning, they reduced 1 hour of work per day and 4 people, which we know that 4 people in a whole project will of course represent a reducing in the costs significantly. So this is the story about this. So in conclusion, once again, our 6 pillars or 6 key factors: weight reduction, reduction of accessories, easy and intuitive assembly of parts and accessories, reduction of pieces per square meter, safety system optimization, and allow for a mix of movements where, or the productivity itself to work like a hybrid, in a hybrid system with cranes and labors, like the example that I just showed you. So basically, this was the presentation that we wanted to show you. I hope you have find it interesting. And we hope to do a lot of more of these. Of course, we can talk about many topics that will be very important and productive for your projects. So thank you very much for having me. And let's see if we have some questions. And once again, thank you.
Thank you, Santiago. All right. Now we are going to have 3 minutes in order for you to write your questions in the box below, the Q&A. So let's see if we have already 2. It says, the first one says, what is the difference in performance between the traditional construction system and the monolithic system?
Yes, very interesting question. With the 2 kinds of system, we will be able to pour a house daily. Mainly, if it's not monolithically, we can have 1 wall and one slab in the same day. But the difference between them will be in the labors, in the amount of labors. Because if we do it separately, like I said in the presentation, it's gonna be harder in the independent system to get good plumbs, to get good levels. The slabs are not going to be supported. In the same aluminum formworks, they're gonna be like, in the air. So we're gonna need lots of proppings. So what we can say that the amount of labors it's going to be around 20% more of labors. Yes. So for example, if we have a 60 square meter apartment and we are doing it with 10 people, by doing it separately or in the independent system, we will need at least 12. This is the reason why we will need more people. And I'm just talking about the assembly process, because in the finishing process, it can be double because of what I said. The internals repairs on the wall slab junction, and in the facades we're going to find some details that of course will make the amount of labors needed a little bit higher, and this will impact our costs in the project significantly.
Excellent. Well, the second question is, based on your experience, what will be the average daily, monthly concrete pouring performance with Forza system?
Like I said, we always aim to do a daily pour. This will depend on the size of the project and the amount of square meter acquired. Like I said, the possibility to be able to pour large amounts of cubic meters in one day. But yeah, basically in our experience, we can do 6 pours per week, you know, in a work week of 6 days. I mean, from normally in this kind of the world, from Monday to Saturday, we will be achieving 6 pours a week. This will mean at least 24, 26 pourings per month. So basically, in a year, we can talk about very confident to have almost 300 pourings in a year. So if we had a non-stop working project of towers of apartments that are 300 housing units, we would be able to do them in 1 year.
Excellent. It depends on the type of the project, the square meters of the plan. Okay, all right. Thank you.
Perfect.
Well, we don't have any more questions, so I guess we can go to the finish of this webinar. Thank you, Santiago, for this great presentation, and especially for everyone for joining us today and for your active participation. We will continue having webinars, presentation in different topics related to the construction sector and all the solutions that we can provide for you. Have a nice day. We look forward to meet you again soon. Best regards from all the Forza family, and always remember, with Forza, any work there is ever alone.
Thank you very much. Bye.
Bye.